All right, so now that we know how to simplify or work with complex fractions, let's go ahead and practice that with some more examples. Again, I like to go ahead and use the LCD trick, where I multiply the top and bottom by the LCD, basically to clear fractions. So that's what you're going to see me using predominantly throughout this page. So for the first one, we have a subtraction statement up in the numerator, and we have an addition statement down the denominator. So we basically have a very complex fraction. So our charge, is to find the LCD. So let me go ahead. We got 4, we got 7, we got 2, we got 10. So if I factor everything and then bring everything together, right, we have 2 times 2 is a for sure. We got to bring down the 7. The 2 is already accounted for. And then we need a 5. So we're basically looking at 35 times 4, 0, 2. It looks like we got 140. So 140 serves as our LCD. So I'm going to multiply the top. Since we got some fractions, how about I rewrite 140 as 140 over 1? But I'm basically multiplying the top and the bottom by my LCD. If I do a distribution, we got 3/4 times 140 over 1. Take away 2/7 times 140 over 1. All that divided by, again, another distribution, we have 1/2 140 over 1 plus 1/10 140 over 1. So going through and doing all these, this one right here, the top left looks a little hard. So how about we 4 goes into 140. Let me do a little math here. 3 times, actually right here, right? I don't need all that, right? So basically we got 2, and then it looks like 35. So we got 35 times. So 35 times 3, I believe that's 105. So we got 105 minus 7 goes into 140 20 times. So 2 times 20 is 40. 2 goes into 140 70 times, and 10 goes into 140 14 times. And that's a plus statement. So I think I got everything accounted for. So doing my subtraction, let's see, 105, 95, 85, 75. This is 65. And then down below we get 84. So last but not least, I got to continue to make sure that this fraction is truly in lowest terms. 65, I think, breaks down into 5 times 13. Neither one of these factors goes into 84. So that is our final answer. So this complex fraction basically simplifies into 65 over 84, and we're done. Next one, a little easier. Like I said, that's probably as hard as it's going to get. There's so many fractions, pretty big LCD. I guess I started with the hardest problem first. For the next one, again, we're having an addition statement and a subtraction statement. So we clearly have a complex fraction, and the LCD is relatively simple here. It looks like it's 12, right? Because the 4 and 3 both go into 12. So I'm going to multiply the top by 12, and I'm going to multiply the bottom by 12. Right, there's my multiplication by 1. Distributing, 3 times 12 is 36, plus 1/4 of 12, well, that's a 3. Distributing down here, 12 times 2 is 24, minus 1/3 of 12 is a 4. So 36 plus 3 is 39. 24 minus 4 is 20. So again, that might be the final answer. 39 is 3 times 13, and none of these go into 20. So that again tells me that that final fraction, right, is simplified. So this complex fraction simplifies into that fraction down there. So there you go. There's our little LCD trick. Looking at letter C, if we could use the LCD trick if I wanted, but when I look at this real closely and just kind of take a step back, notice that I have a fraction up in the numerator and I have another fraction down in the denominator. So it's not quite like letter A or letter B where we had sums and differences. I just have one fraction and one fraction. So how about we go back to, I think it was 6.2, and let me rewrite it like this. This is a plus 5 over a squared divided by a minus 2 over a. And now that I've rewritten that the way, we can just basically see we're dividing fractions. So we learned back in the day to do that, we simply multiply by a reciprocal. All right, and this a will divide out with an a down there. So it looks like we have a plus, well, let me make that better. Still getting used to work on an iPad screen. We have a plus 5 up in the numerator and a minus 2 down the denominator. No more common factors, so we're all good to go. So we didn't even need our complex fraction trick here. We just simply had to, it is a complex fraction because I have a fraction that has a fraction in the numerator and the denominator, but it's basically just a dividing fraction. So we're all good. D, though, we're back to adding and subtracting. So we have to use our LCD trick. So in this case, it looks like the LCD is 4x, right? 4x on the top, 4x on the bottom. So I'm going to multiply the top by 4x, if you want to think of that as over 1, and multiply the bottom by 4x, and if you want to, 4x over 1. So again, I'm multiplying top and bottom by 4x. If we distribute, the x's will cancel out. 2 times 4 would leave us with an 8. If we distribute, the 4's will cancel out. X times x leaves us with an x squared. Down below, if we distribute, the 4's will cancel out, and we have a 3 times x. And we're taking away, the x's will cancel out. 2 times 4 is an 8. So if I rewrite some things in descending order, right now, that looks like my answer. Okay, and in terms of finding a common factor, making sure reduced, we saw back in chapter 5 that the only time a binomial factors is if it's the difference of squares, which this is not, right? It's a difference of cubes, which it's not, or the sum of cubes, which it's not. So that's factored. And then this guy is a linear factor, so it's factored. So that means we're finished. There's our final answer there. Nothing to factor, no common factors. Okay, so I am almost 7 minutes into this, and I know letter E and letter F are a little more complicated. There's more going on, more powers and whatnot, but we're going to continue to use our LCD trick where we're handy, and I'll do that in some videos coming soon. All right, talk to you later.